Hi, welcome to CAP Quantum Academy for Physics. In this lecture, I am going to start units and dimension, and this lecture will be useful for both ECET students and intermediate first year students. What are units? Units are nothing but the basic reference standard for measurement of a physical quantity. What is a physical quantity? Which is measurable. Physical quantities will be measurable. Okay, for example, I have taken a line and I want to know the length of this line. Here the physical quantity is length. Okay, I want to know the length of this line. See, what are units actually? The basic reference standard for measurement of a physical quantity. If the length of this line is 5 centimeter, 5 is nothing but magnitude, a number, and centimeter is the reference standard I have using. For measuring length, the units are centimeter, meter and kilometer. Okay, and the length of this line is centimeter, 5 centimeter. And the centimeter, meter or kilometer is known as unit. Okay, it is the reference standard. Unit is a reference standard which is used for measuring a physical quantity. Okay, I hope you understood. And these units are of two types. One is fundamental unit and the other is derived unit. One is fundamental unit and the other is derived unit. You just copy these whatever I am writing on this board. Fundamental unit, one is fundamental and the other is derived unit. What is a fundamental unit? The units for base quantities. Fundamental units are nothing but units for base quantities, base physical quantities. Okay, generally we have 7 fundamental physical quantities. 7 fundamental physical quantities. The units which are used for measuring these 7 fundamental physical quantities are known as fundamental units. And coming to derived units. What are derived units? A combination of fundamental units. Derived units are nothing but they are combination of a fundamental units. Okay, now I will explain a little more about these fundamental and derived units. And one more thing, the set of fundamental and derived units. Both these units are known as system of units. Set of fundamental and derived units are known as system of units. In general we have 3 such system of units. In olden days, in our past years, different scientists from different countries used different system of units, and those system of units are nothing but CGS, FPS and MKS. CGS, FPS and MKS. In this system of units, the length, time and weight are measured in terms of, for CGS system, centimeter. Length is measured in terms of centimeter, and gram for weight, for measuring weight, and second for measuring time. And coming to FPS, foot, pound and second. And coming to MKS, meter, kilogram, gram, kilogram and second. See here the length, weight and time. Length, weight and time is measured in terms of CGS, FPS and MKS system. These are the different system of units used in olden days. But at present, the system of unit used are SI system of units. A general body decided for following a single system of units, which is nothing but a SI system of units, which is known as international system of units. This international system of units is abbreviated as SI. There is no full stop in between SI. Okay, and this is developed and recommended by General Conference on weights and measurements. The group of scientists under General Conference on Weights and Measurements had derived this international system of units and is abbreviated as SI system of units. And this General Conference on Weights and Measurements in terms of SI system of units had given as 7 fundamental physical quantities. 7 fundamental physical quantities. Okay, what are those quantities? I will explain in a tabular form. You just pause the video and copy all these. Just please ignore my handwriting. My handwriting is not that good. And what are those 7 fundamental physical quantities? SI system of 7 fundamental physical quantities. SI base quantities are fundamental quantities. Fundamental units are known as base units. Okay, SI base quantities, physical quantities, and the units which are used as reference standard for measuring these 7 base physical quantities are, I will explain in a tabular form. Here I am taking base are fundamental quantities, and the name of the unit which is used for measuring these base quantities, and the symbol which are used for representing these units. Okay, and 7 base quantities are, first one is length, and second one is mass. Listen carefully, very important tabular form. Time, electric current, thermodynamic temperature. Thermodynamic temperature and amount of substance. Amount of substance, luminous intensity. Final one is luminous intensity. These are the 7 fundamental physical quantities which is given by the international body. Okay, and name of the units for these fundamental physical quantities are: length is measured in terms of meter, and mass in terms of kilogram. See, before writing the name of the unit, you have to remember one important point. Note, you just note important point. You just write. I will explain. Okay, note. What is the note? The name of the unit must be written with small letters only. Even the first letter of the unit also written in the small letter only. Even the scientist name also written in the small letters. Okay, this is a note. And the time is measured in seconds. Electric current is measured in ampere. See here, this ampere is a name of the scientist. This name of the scientist must also written in small letters only. No capital letters. Don't use the capital letters. This is a rule for writing name of the units. Thermodynamic temperature is measured in terms of Kelvin. These are SI base units. In terms of in CGS system of units, length is measured in terms of centimeter, mass, grams, time, seconds. Ampere is converted. These are converted into other form. Okay, I will explain. And the definition of these fundamental or base quantities I will also explain in our next lectures. Here I am stressing for ECET students. This lecture is mostly for ECET students. Okay, there no need of writing all the definitions of the fundamental physical quantities. Okay, you have to know the basic rules like writing the name of the units in small letters, and length is measured in terms of meter, mass, kilogram, time, second, electric current ampere, thermodynamic temperature Kelvin, and amount of substance is measured in terms of mole. Luminous intensity is measured in terms of candela. Candela is also a name of a scientist. And coming to symbols, you have to write a note here also. Note for writing symbols. Name of the scientist. Is represented with the capital letters. Remaining symbols are represented with small letters. Okay, name of the scientist is represented with capital letters. Remaining other basic quantities are represented with small letters for symbols. But for coming to the name of the units, you have to use only small letters. So length is measured in terms of meters, and the symbol used is m. And for kilogram, kg is not an abbreviated form of kilogram. Okay, it's a symbol for kilogram. And second, small s, ampere. See here, scientist name. Ampere is the scientist name, so I am writing the symbol of this ampere as capital A. And Kelvin is also a scientist name, it's also a capital letter. And mole, the symbol for mole is MOL. And candela, capital C, small d. It's also not a short form or an abbreviated form of candela. It's a symbol for candela. Okay, so these we have two rules. One is for writing name of the units we have to use only small letters, also for scientist names. And coming to the symbols, you have to use capital letters for representing the name of the scientist, and remaining are small letters. Okay, this is about fundamental physical quantities, SI, base, physical quantities and units, and symbols for representing the name of the units. In my next lecture, I will explain about derived physical quantities. And after derived physical quantities, in one more lecture, we will solve few problems relating to the fundamental physical quantities and the derived physical quantities. Okay, be prepared. You just go through these rules and the name of the units and the symbols. Okay, derived physical quantities, derived units and derived physical quantities. Units are of two types, we know that. One is fundamental units and the other is derived units. What are derived units? Derived units are a combination of fundamental units. Okay, we know that we have 7 fundamental units. We are combining them. We are combining these 7 fundamental quantities. We are combining 2 or more fundamental quantities or fundamental units to form derived units. For example, I am taking force. According to Newton's laws, what is force? Force is equal to mass into acceleration. Mass into acceleration. Here, what is acceleration? What is the definition of acceleration actually? It's a velocity, change of velocity with respect to time. Change of velocity with respect to time. And definition for velocity is, what is definition for velocity? Displacement by time. Okay, displacement is measured in terms of meters. Why? Because here we are measuring the length. What is displacement? Final point minus initial point by time t. Okay, velocity. Here I had written only the definition for velocity. Okay, and we left with time. In the denominator we left with the time. Okay, so what is velocity? Displacement per time. Displacement is nothing but final point minus initial point by time t. Here what we are measuring? Length. Length is measuring in between final point and initial point. So what is a fundamental quantity, fundamental unit for length? Meter, right? And for time, second. Okay, now you just write force formula, mass into acceleration. Okay, mass into acceleration. Mass is measured in terms of kilogram. Fundamental unit for mass is kilogram into what is acceleration? Velocity by time. What is velocity? Meter per second. And here one more quantity we have, time, second. Okay, into 1 by s. Now units for force is kg meter per second square. This can also be written as kg meter into s power minus 2. Okay, in the denominator we have second square in the denominator. If you bring this to the numerator, you can write it as s power minus 2. So units for force SI units for force is kg meter per second square. I think it's not visible here. I'm writing here. Force units are kg meter per second square. Okay, here we are combining the base quantities, base units. Okay, kg is used for measuring mass and meter for measuring length and second for measuring time. Here we are combining mass, length and time. That means a combination of these three physical quantities is known as derived physical quantities. Two or more, we are combining two or more physical quantities. Okay, these are known as derived physical quantities. And the units which are used for measuring these physical quantities are combined together is known as derived units. Here we are combining, here kg meter per second square is combined together to derive a formula for force. These are about derived units. I will give you a few more derived units for derived physical quantities. Just pause the video and copy all this, so that while revising for your exam, it will be easy for you to understand. So I'm going to explain in a tabular form for easy understanding purpose. I'm writing here the physical quantity as usual, same as fundamental physical quantities. Here derived physical quantity, derived physical quantity in this column. Okay, and here I'm writing the SI unit, SI name of the unit. Here I am using International System of Units. Okay, here I am writing the symbol for representing this name of the unit. Okay, area, coming to, I am explaining about area. Area is nothing but a square meter. It's a square meter and the symbol is m power minus 2. Okay, meter is a measurement for length. It's a unit for length and it's a square meter and a meter power 2. Okay na? And volume is cubic meter. Cube, m power 3, m cube. And speed and velocity. Units for speed and velocity are same, that is meter per second. You just revise all the definitions. Okay, otherwise I will try to explain the definitions of all these physical quantities in one lecture. I will try to make a video for these definitions of these physical quantities. Okay, speed is nothing but meter per second. Velocity is also measured in terms of meter per second. Distance per time, displacement per time. Okay, meter per second is nothing but by s. Okay, this is this symbol is denoted for division. Okay, and this also can be written as m into s power minus 1. There must be no gap here. There must be no gap in between these two symbols. And angular velocity, I will explain the rules for writing the units, SI units, in my next lecture. Angular velocity is a radian per second. Radian per second. What is radian? I will explain in the last. I will explain in the last of this video, at last minute of this video. And rad, symbol for radian is rad, R-A-D, by second S, or can also be written as rad into S power minus 1. And wave number, next one is wave number. Shall I erase this? I will erase this. You just copy by pausing the video. We know that we have 7 fundamental physical quantities. Including those 7 fundamental physical quantities, we had 2 more physical quantities. Okay, I will explain about them at the last ending of this video. I will explain about them. Okay, and one more is wave number. Wave number. You just go through these definitions. Okay, for learning about units, you have to know the definitions of these physical quantities, so that it will be easier for writing the name of the unit and the symbols. Without knowing the definition, you can't write this name of the unit and the symbols. Okay, you have to know the definitions. If you won't know, using these units, you can also derive. There will be few rules for writing the name of these units. Okay, using the name of those units and dimensions. If you learn about the dimensions, using these dimensions also, you will be able to derive a definition for the physical quantities. After learning the dimensions, we will solve problems for deriving the formula for the physical quantities. Okay, no need to worry. Wave number per meter. Per meter. This per is used for division, for representing division. Per meter is nothing but 1 by m, or can also be written as m power minus 1. And the other is current density. Current density. You just please adjust with my handwriting. Current density is measured in terms of ampere. So scientist name you have to write in small letters only. Ampere per meter. Ampere per meter. And the symbol, you have to represent the name of the scientist in capital letters. Capital A by meter, M per m, or capital A into m power minus 1. I will explain about the rules for writing this name of the units and the symbols. No need to worry. Okay. And one more is movement. Momentum. It is denoted with P actually. Okay, momentum. Momentum P equals to m into v. Okay. Kilogram into meter per second. Okay. Kilogram is symbol is kilogram for symbol for kilogram is kg, meter m, per second, that is s power minus 1. So these are the few derived physical quantities and the name of the units for these physical quantities and symbols which are used for representing the name of the units. Okay, in my next lecture I will explain about the rules whatever we have to follow for writing the name of the units and the symbols. Okay, bye.